Leah, that's your cue. Awesome. Finally, I'm excited to introduce today's guest as Jonathan Crabtree. He's the Assistant Director for Cyber Infrastructure at HW Odum Institute for Research in Social Science at the UNC Chapel Hill. And Jonathan will be presenting on the remote storage for Dataverse. So Jonathan, take it away.
Just up there at the top, share screen.
All right, can everyone see the PowerPoint now?
Yes.
Okay, cool. All right. So I want to talk a little bit today about a project that we're working on and the ramifications it will have on or potential uses, let's say, for Dataverse and other things around Dataverse, because I think that this project, while interesting and can be used for the exact use case, I do think some of the tools can be used for many other use cases. So as I mentioned before, I'm here at the Odum Institute. We were founded in 1924. We're kind of excited this year. This is our 95th anniversary. So go online, see our Twitter account for all the different things we're doing this year. We'll culminate with a big thing in October, but we're doing seminar series and all sorts of really cool stuff leading up to our 95th year. But I want to talk a little more about the Impact project. This is an NSF-funded project. And what challenge we were looking at. The challenge we were looking at was how are we going to help people manage complex data sharing issues. In many cases, it's multi-institutional, governed by lots of different policies. The social science world has tons of privacy issues. So how do we deal with all of this stuff? When you can't just upload it to Dataverse. Dataverse has been great for the de-identified stuff, but we really didn't have a solution that wasn't just upload the data to Dataverse. So the goal was to come up with a cooperative process where we talk to all the stakeholders involved, all the way from the data providers to infrastructure providers, all the different people along the research lifecycle, and work with those folks along the way. So the approach was to develop these trust models between the collaborators and use diverse methodologies, leveraging things like secure networking, data management, to preserve the privacies and all the different MOUs and use cases that all these different groups have. And as we started looking, they were very diverse, and some were simple and some were super complex. And how do we lower those barriers to let people share restricted data or private data in these collaborative settings? In some cases, users didn't want to share it at all, that they wanted to have a gatekeeper kind of stand in front of that. In other cases, we had to come up with things like secure multi-party compute, which I'll talk a little bit more about that later. But we had to come up with a way to share between universities, between public entities, between government entities, and all of those seemed to be different. So they had different trust models between all of them. So we tried to come up with a way to model those trusts. So this is an image of the workflow from Odum's perspective and how we're going to leverage this system. And it includes several major components. At the center of this is our Dataverse. Dataverse is where we share metadata. We want to keep that in the middle, but we also have data that we know are going to be, and I don't know if you can see the pointer here, but over here in this trusted remote storage agent, there are cases where this data is too sensitive to upload into Dataverse, and we want to keep this in a remote storage area. So this is by university policy, by IRB policy, many cases that we have to have this secure file system that sits outside of Dataverse, but we want to be able to share that with collaborators and use it in a collaborative environment. So the goal here is to keep this data in this secure environment, but push all the metadata into Dataverse and push enough information into Dataverse so Dataverse knows how to access that. Now, in our specific use case, we're creating something called a notary service that manages access. It is basically the gatekeeper that checks all the policies to be sure all the MOUs are correct, make sure the environment is correct that you're using the data in, make sure you are who you say you are, make sure if you needed IRBs signed, all the different levels. We looked at several different models for this, and we needed some very diverse models that had different ways to come up with workflows for that. So we collaborated with the folks at Duke University that have been working on this thing called it's called SAFE, and it is an algorithm that allows you to encode those policies into machine readable languages that can be key encrypted and shared between machines. So Impact is going to leverage that notary service and coordinate with that SAFE policy server, and actually they'll probably be rolled into one actual unit. They'll talk together there, and then we created a gatekeeper, basically sits on top of the storage that protects that storage, and that's that SAFE client that we see over here, and it communicates with the environment that the compute will be in, and we'll go through some of that as I step through some of these different components. So the major components of this thing are the trusted remote storage agent. This allows you to create the metadata needed to push it into Dataverse. So the first challenge we had is some of the rich metadata that we want to use for social science is in the variables and actual data itself. So many of you know that Dataverse computes these variable level metadata on ingest. The data file is moved into Dataverse. Dataverse does some actions on it to create DDI-based metadata at the variable level. If Dataverse cannot get to the data, it cannot create that. So we had to bring that outside. So we generate these variable level metadatas in that TRSA environment, format the JSON, and then push that into Dataverse. Dataverse is how we're going to share metadata for this process. And then the gatekeeper, or the person who validates all the keys, is that notary service. And then the policy server computes all these policies, and then you're handed off into a secure compute environment. And we have two different ones of those where, technically there's actually three. There's one at Duke, there's one at Odum, and then we have a third, which is a secure multi-party compute algorithm that we're doing for the National Institute of Health, where people don't share the data with each other, that the compute is computed on these multiple databases that are private and secure, located in 3 different locations. And Presidio is the gatekeeper. That's the safe client that we've developed that sits on top of your data store. So if you wanted to leverage something like this, what you would have to load on top of your data store is that TRSA remote storage agent and that Impact Presidio. Those are the things that sit in your local instance on top of your data store. Everything else is remote. One thing to note too is that by design, all of these things can be used individually or choose and mix and match them. So for example, if you have your own secure computation environment at your local university, you can substitute that in for some of these things that we've built. There's nothing says that those can't be plugged in and plugged out and pulled out. You can do it remotely. You can have a remote as long as you have the appropriate networking. You can do this from a remote site. It doesn't necessarily have to be within that enclave. Everything's done with virtualization, so you can use however you would like. And it also can be used for other use cases. We're doing it for this project for sensitive data that can't be moved because it's sensitive, but many cases exist that data can't be moved. Either it's too large or other reasons that it can't be moved, not necessarily just because it's sensitive. So we start with managing the metadata with Dataverse. This is basically a stock Dataverse with only a couple things that we're working on, and some of this we're still working on. We haven't actually changed the core of Dataverse yet. We've been working through all the APIs up to now, but basically we're going to use the templates and all the features in Dataverse to create the landing place, or the place where all this data will stay. And as you notice, we are planning on changing these. So right now in Dataverse, you go to explore data or download data, and it expects the data to be local. In most cases, I think there's some S3 cases where it's not local, but most of the time Dataverse is all in the local file system. We're working with the folks at Harvard to come up with a way to create options for this. So in our case, for example, this will point to a notary service, and very soon we'll have this pointing to our notary service here, but we're designing it as such and want to work with the Dataverse community where this doesn't necessarily have to come to a notary service. It can go to wherever your remote access is. So we want to create table structures within Dataverse that realize that Dataverse could have the data locally, or it could be in one of these notary service controlled locations, or it could be in Globus, or it could be in S3, or it could be any remote storage for any reason. So we want to come up with a way to do that so everyone can leverage this. The reason we haven't done it, just did it for ourselves, is because we want to coordinate this with everyone. We want to be sure that we cover as many use cases as we can so that everyone can leverage this ability to have a remote storage location, whether they use our TRSA or not. So that's the key to this, is we want to make it adoptable for all the other Dataverses in the community. So we use standard stuff like the Dataverse templates, and we have language in there that ties it back to the impact registry. So that's all pretty normal Dataverse stuff, and that won't change at all. Where we start getting into some of the extra tools is this trusted remote storage agent. So before you start with uploading this metadata with the trusted remote storage agent, it has to have a place to land. So you have to create that data set within Dataverse. So you have to have that. And in our case, we have an impact Dataverse specifically for this. But this really could push it to any Dataverse as long as you have the information to set that up. You start off in TRSA by configuring the actual Dataverse that you talk to. So you configure here the Dataverse that it points to, and this is probably pretty bad security practice here, putting an API token on a public site, but this is a test machine and it gets changed and wiped out pretty often. I think it's not too bad. But you put your API token, and this allows the TRSA to talk to that Dataverse. It has a local file system. It has things like the notary service URL. Where is the notary service for this? And where do you get the safe policies from? And this is the Presidio that kind of is the gatekeeper for that. So as I mentioned, the first thing is to point TRSA at the right Dataverse. And as you can see here, we've got a couple test cases, and I've created a study called Crabtree Test Dataset, and it sits over there on the Impact Test Dataverse, and this will be the target for all that metadata that gets collected and moved over to Dataverse. Excuse me. So once you're ready to choose this, you actually upload and ingest the file. In this case, what we're doing is we're putting this into a temporary location and running code on it that was adopted from the Dataverse ingest code and runs locally, and it generates all of the variable level metadata. It creates a local data set for that, and it tracks all this, so you can track exactly what you've pushed to Dataverse and compare the two, compare that Dataverse to the actual local destination. And once you choose the destination here, and then basically you package all of this up using the JSON package, and then you publish it to that data set, and it pushes it over to the Dataverse. So now that this data is in Dataverse, how do you get access to it? So the file access is coordinated by the Notary service. And eventually, and right now we don't have that, there will be a button for each one of these studies where instead of downloading the file, you're carried to this Notary service. Notary service is kind of the gatekeeper for all of this. And there's many components of this notary service, and it works through managing all of the different policies and encoding those policies so they're machine readable, and it uses encrypted key technology to authorize and to verify all those policies. So what types of things is it doing? It looks at policies defined by the data provider. Things like, do you need an IRB? Things like, have you been trained? For example, ad health data here at UNC requires that you have a certain level of training. Some data sets you have to pay a fee to get to. Have you paid the fee? Those kinds of things. Notary Service turns these things into workflows, and we'll look at some of the workflows in a few slides down, where those workflows can guarantee that before you move on to the next part where you get access to the data, that each of these policies have been validated, and each policy has been encoded in this safe policy language so that they're machine readable. The key is that Notary Service validates all of these authorization keys and tokens, and then Presidio, sitting on your data, asks Notary Service for those keys to validate that this user is who they are and they're coming from an environment that it's safe to share the data with. So it's aware of not only the data requirements but and the policy requirements, but also the technology and where you're coming from. The same person can come from their laptop at the Holiday Inn and it's not in a secure environment. But if they come from one of the secure enclaves with the same set of keys, then those keys would let you in. So it manages the difference between your technology you're using that you want to analyze that data with. So in Notary Service, these projects shape the data, and in those they identify that authorized users, the infrastructure providers that are authorized, the types of data sets that are in that project, and the workflows and the institutional governance, which IRBs need to be contacted and verified that all these policies have been encoded. So it looks similar to this, and this is just a quick snapshot. Towards the end, I'll open up and we'll go live to some of this, and we'll see if a live demo actually works. It may break, but that's okay too. That'll be fun. But basically, it allows you to determine who are members of this team, and it uses validation from your local logins back to the actual members within these staff ownerships, these active memberships. It uses something called CI logon to manage this, and when we look we'll look a little closer into the enclaves a bit later. But when you come in, you actually come in with CI logon, and then it will cross-reference you to your project and give you the access you need or which role you will need. And we'll look at some of those roles when we do our live demo. It also allows you to select the infrastructure. So here for this demo project, the Odum Secure Enclave has been validated. And what it means by validate, it means all the policies have been written correctly, number one, and two, that they've all fulfilled all the obligations for this project. And those are validated. You can you validate those a little along. So for example, these data sets here, these policies have not been validated, and you'll have to go through to get access. Before you can get access and gain access, you'll have to go through that validation process. So for example, you may have to have an IRB signed, or you may have to have training or one of the other workflows issues, and we'll look at some of them a little bit later too. So this notary service concept, it basically is just like a notary in the real world. It negotiates it makes sure that all of these parties agree and that all of the electronic copies of these documents have been signed and haven't changed, and that this infrastructure provider has told the notary service all the different variables around that infrastructure, and that the data provider agrees that this infrastructure is okay for their data. And all of this stuff is, this PDP is actually that policy data protection that sits in front. That's the Presidio that sits in front of the repository and manages the access. So Notary service really doesn't control the access. It just manages all of the keys. The access is actually controlled through this PDP. So one of the keys to it is this technology. So here at Odum, we needed some sort of secure enclave where we could have people operate in a secure fashion. The folks at Duke developed their Protected Research Data Network. The social science research group at Duke developed that based on something called ProConsole. And we took it and adapted it, changed it slightly. We used Singularity here, and we changed some of the virtual imaging. And of course, we had to use some of our local infrastructure here at UNC to spin up these virtual machines in a secure environment. One key to these enclaves is that when you go into that environment, you're actually acting as a surrogate, or you have a surrogate acting for you, and it should be how it's said. So there's a surrogate for you in that environment operating on the data, and those keys that it uses are temporary. So it operates, it gets authenticated through the notary service, it operates on the data, and when you're finished with your operation, those keys go away, so no one else can come in and pretend they're you, because those keys have to be redone again. So there is those keys and the users themselves actually spin up when you log into the system, and then after you're through your operation, it's gone. The user itself goes away, the key goes away, and when you come back in, you come back as a fresh machine or fresh user. So we use something called ProConsole that they did, and basically this maps between your CI login users, which can be any university, and maps it to these groups and sets of users that are allowed to use this environment. And this environment is approved based on a set of policies for certain data sets, because all data sets couldn't use this policy or use this environment. They may need this secure multi-party or some other type of environment. It's pretty simple once you get through the authorization and spinning up the VMs. Basically what you get is a virtual desktop. In this case, this is a Linux desktop, and we spin up some software for you. And we use the software container tool called Singularity, and the security department scans each one of these containers. So basically you have any choice of these containers, and we've started with a handful that our first use cases would like to use. But what we'll do is we'll scan these containers, we'll load them, we'll scan them. We have it set up using a Jenkins workflow where if someone makes changes to the package, that these things go through the security process and get approved. And as long as they follow the Jenkins workflow and everything is compiled correctly, that they show up here for users to use. So once you're in your Linux environment, you can spin up any number of Singularity packages, and that's how we get the apps into that environment, rather than users having to install apps, or we have to predefine apps in for users. Building multiple images would be very laborious. We'd build 1 or 2 base images, and then we let people load the apps using the Singularity mode. So how do people get to this thing? So when you go to Dataverse and you discover some of this data, and you find out that, hey, I would like that. So this researcher negotiates access through the notary service, and then they have made some the infrastructure provider has given some guarantees to notary service that if this researcher uses this remote environment, that this data provider says that's okay. Notary service hands those keys over to the virtual enclave, and that unlocks the ability for this researcher to actually get to the data itself. So you go through this remote desktop. Basically, they get them inside this virtualized container. You get the Linux box, and then the software repo is where the Singularity container is, and these are all signed and guaranteed that they haven't been tampered with, and they get moved into this enclave, and then the researcher has access to the data. So then the person can work on the data within this enclave. That's how the Odum enclave works. But in some cases, and this is one of the cases we're testing, in many cases, there's a database that no one wants to share. So you don't mind people doing compute on certain portions of it, and there's algorithms within secure multi-party compute. And to be honest, I have no clue how these things work. Eric Scott from Rentsy manages this compute environment here, and this is a slide that he provided that allows these researchers using a cryptographic method to actually work on 3 different databases and get valid results, even though this researcher cannot see any of this data. They just do the compute on portions of it, and they build these cohorts building on different private databases. I've seen some of it in action. It's very interesting. I don't have that use case here at Odum. The folks at NIEHS have several use cases, and they're testing that right now. And hopefully we'll be able to include that as another approved environment within the Notary service, although it's still in testing right now. So how do we move from the world of MOUs and text-based things into these safe policies? Right, that's the million-dollar question. How can a machine read your MOU and validate that you've actually done some of this stuff? So we break it down into different assertions. So for example, these are some simple ones, and I'll show you some more complex ones a little later. But the first thing is, are you affiliated with that research institution? Are you a member of the UNC trusted group in our case here? So a safe makes that assertion that the member is from that institution where this project has endorsed it. And then there's a set of safe policy rules that encode that in a set of assertions that can be read by the system, the safe server, and compare them. And they get quite complex as you move into more and more, if they have this, they must have that. And there's a lot of variation around these policies, and I'll show you a graph of some of that a little bit later. But basically, you're encoding some of this into this safe policy language. And what we're going to do to start with, we're going to provide some templates for people that if you have these requirements, these are the rules that must be enforced. So when the researcher wants access to the data, the key to the access is handled within this Notary service and using a REST interface that actually looks to see if all of these individual policies have been satisfied. And if they've been satisfied, then there is an authentication request in one of these Java web tokens that's sent back to the server, says, yes, here's the key to the data, and all of these have been validated. So you can go through all the different certifications within each level of this and validate those tokens as you go through that workflow. And I think we got here's where one of those workflows looks like. This is more of a complex workflow from Ad Health, and in many cases, things like have you submitted an IRB, have you abided by the IRB pledge, and then IRB has said yes, and then they've been approved, and now you have access to the data. Or you could have things like, are you on a server or a workstation? Is the server used in other products? Or have you made the pledge that you've encrypted your laptop, for example? And then has all the other workstation security protocols been followed? If it's on a server, did you have other security protocols? So the workflows, all of these workflows are encoded in safe policies, and you don't get to the next policy until all of these things have been satisfied. They work their way down through this. Now, this is the entire workflow, but as you notice, some of these workflows are for the user, some of them are for the technology side, some of them are for IRB. So there's different groups involved in creating this this template of access, and all of this is coded.
I was listening to a webinar. Hold on.
All of this is encoding in this file contents down at the bottom, and when we go live, I'll show you what this code looks like. Basically, it's encoded in XML, and it's lots of these safe policies followed by each other, one behind one. So then once you have all of these things satisfied, you can go into that project and generate an access token. Now, we haven't operationalized this. This is actually just a test right now to be sure Notary Service can talk to Presidio and Presidio can send the right tokens back to Notary Service. As I'll mention later, we're gonna the next steps is to put this on top of some real data and traffic and control the data access traffic with Presidio. Right now, there's just some mock-ups of that. But basically, you generate this access token here within the Notary Service, and you send that to Presidio. Presidio receive it to make sure it's a valid token, and if it gets a valid token, it'll send you back a message, and I'll show you that live here in just a moment as well. So right now, we are getting close to the TRSA prototype being complete. We haven't done any user testing other than in our project group. We want to start moving this out to more and more users to make things a little easier to use. We haven't done any of the usability testing yet, so that's really critical. We're hoping to do that over the next few months. We're hoping to have a prototype of this connection from Dataverse to these remote data stores. We want to demonstrate that in June when at the Dataverse meeting. We'll have a demo of that prototype, and we'll be hopefully getting more feedback so we can make that more robust so other groups can add different types of data to it. Presidio, as I mentioned, we are testing the Presidio. Presidio is functioning. We have not put it on top of the real data yet. That's the next step. The data Notary Service GUI is really, really close, and we have our enclaves complete already. So if I can figure out how to change what I'm sharing here, let's see. I want to go live right quick.
You should be able to select under the screen share what you want to share specifically.
Yeah, that's what I want to. Let's see if I can come right here. All right. Now, did it change to where you're seeing Firefox now?
Yep.
Okay.
Yes.
So, let's see. Make sure everything's up here. So this is our, we've been playing around a lot this morning here, changing things. So this is the Impact. This is a data set I created with Impact in our Impact Dataverse. And basically this is a data set. It's just a landing page. We use the standard metadata formats, templates where we could put information in here for different types of contributors. In our case, the distributor is our remote storage agent with the Notary Service here. So if we wanted to push something into here, and I've done a few of these, and we'll see if this actually works. Get right here. Okay. So this would be our trusted remote storage agent. And the first thing you would do if you wanted to set one of these up, you come over here and manage your. Let me make sure I reload this. You would manage your profile. You would need things like the email of the administrator, where your let me do this. I can edit it. Where your Dataverse URL is, the API token, how you get access to that, where your file system located for your local file system. So when Presidio lets things in, how does it know to traverse through that file system? And of course, where your in our case, where your Notary Service URL is. So who is the gatekeeper? How do we manage that stuff? So you can have multiples of these. In our case, we only have one Impact, but you may, as a provider, want to share it with multiple different Dataverses, and that's okay in this instance. So once you've set up your actual profile, your profile for this TRSA, so it knows which Dataverse to talk to and how to talk to it, Then you want to manage your different data sets. And in this case, this is the test data set that I set up. And you give it the information. How can it get from TRSA into this? And these are the things that control that JSON packet go in, and how they send that JSON packet, and what the API token is, and that information. So once you have those two things set up, now you're able to upload some metadata into that. And this is where some of the work went. So for example, let's pick one here. Desktop. I should have something here. Here we go. Here's an SPSS portable file that should be doable. So in this case, I want to put this in the temp directory so I can ingest this uploaded file. So basically what it's going to do is just generate all the metadata for this data set. So you upload all that, and here what it's done is it's created that JSON packet. So it's ready to push to that Dataverse. It created all the variable level metadata and all of the item level metadata to push into that data set. And then you come here and select your destination. In this case, I want to put it in that Crabtree test data set that we created before. And then you publish this to your Dataverse. All these actions are recorded in the system. So you publish that to the Dataverse, and it pushed that data up to that Dataverse. And then if you want to go see what it did, you can come here and look into the Dataverse site. And as you know, since Dataverse is versioned, it created a new version because it added metadata there. And if we look in the files under versions, see if it prints. All right. This says 23rd. Let's see if I reload. I should have saw something there I don't see. All right. And then it should be the files. Well, maybe it didn't work. So I must have, we were tweaking this thing this morning, adding some stuff in it, so we may not have completed. So it must have had an error. It should have showed, when I clicked versions, it should have showed the second set of versions, and it's not showing those. Okay, so I'll have to go see why it didn't work. So as anything, so at least we know it's live software when it crashes, right? Once you get to your data sets are here, basically all it puts is the metadata. So let's look here, go back to this data set. So you go into the metadata, and eventually this button here will actually be one of the file buttons. So rather than, let me see if I can back up. So rather than being inside this distributor, which right now that's where we're doing, what we want is this Explorer button here to say go to, one of the options will be go to Notary service. And since it's not local, none of this works anyhow. So there's no reason to do this because the data is not actually here. It can't do that. So let's go. So when you click the metadata, it carries you over to this impact. This is the Notary service. And as I mentioned before, there's many different roles. You can either be in our case, you have infrastructure provider, someone that's providing the technology, someone that's a project member that has access to the data of the project, and then you got project PIs, which has a little more control for that. So I'll just choose the role of a data provider right now, and it allows you to go and see all the different managed membership. So co-managed handles all this membership. So I am a PI here, so I'm a member of all. I'm a UNC staff member here. It takes all of that information that it got out of the in common is what it manages, but it uses CI logon to do that. Excuse me. All the EDU person affiliations, all the principal names, all that information. So it's tracking all of this user information for me as this role here. let's look at the project itself. So I created a sample project here just to test some stuff. And we created a couple admins for this data. And if you'll notice, you got project members, and these are the folks that have access to this data set. And then there's some infrastructure here that I added some infrastructure. In this case, this is the Odum secure enclave, and this is some small text here. But we eventually want to have more information about who can use it and why they can use it, and what that infrastructure is used for. And then you have access to these data. And this is where you would actually say, okay, I want to go see that data here, and this would carry you through all the different codes and the DOIs from where the metadata came from over on Dataverse, or where the actual code is. And of course, this is the test. Presidio is not functioning in front of the data yet, but that would carry you to the actual data, and you can generate your access tokens here. So let's look at, before you access any of this stuff, you have to have these policies. The policies have to be coded. And some of these policies are pretty sophisticated. Some aren't. Let's see this one. So here's one that someone put together, and the file, all these are in, it's in GraphML, is how the database that holds all of these policies. Here is the actual files, the GraphML file that talks about all the different components that need to be, attributes that need to be certified before you can have access to this data. All these files are in our GitHub location, so we can sample these and people can see those so they can test. Let's look at this one here. Here's one that the one that I showed earlier, and allows you to probe through these actual workflows and change things and add things. And we did this as a test so people can actually see all of the policies rather than scanning through all of the text, which can be really long. This is the one for ad health, and there's lots and lots of different policies for that. We wanted to find a way that we could actually share with some of these. And this is just a test. These labels would actually have meaning for the project people, whoever developing the actual project, so we can change some of this language. And then you have the infrastructure that I mentioned earlier. Of course, this is the Odum infrastructure there. So if you look, we go back to, let's see. No, that's not where I want to be. Let's see. I'll find this. All right. So here, for example, once we have this finished, this is a test section for this cancer data. First thing you'd have to do before you can access the data is generate you a token. And you would generate this token, and it encrypts this web token, and so it shows that Jonathan David Crabtree created this token, and these are all the information. This is who I'm coming from. This is all of my information for me as a person. And then once you wanted access to this data, once it's finally done, you would send that to Presidio. Presidio is the gatekeeper in front of the data. So in this short demo, you can click test or click send, and it receives all of that web token and validates this web token. And then you can, once you gain access to the data, it would send back to Notary Service the actual token that would allow you to, in your computer environment, to actually access the data. So this is the point where now you would choose your computer environment, you'd go to your computer environment, and then you would have access to that data because all the tokens have been satisfied. This part is not finished yet. These are just some mock-ups to show that Presidio can take a token and communicate back to Notary Service, yes, I got a token and it's valid. Once we finish this, we're going to start putting it in front of that actual interface. Let's go back over here and here. And So once we get the all these things put together, then we'll be able to do the full workflow. So our next steps, everything is working in different levels of completeness individually. The Presidio works individually, Notary Service works individually, Dataverse is working individually. We got a few components of each that need to be tweaked, but the next big step is to connect them all into an MVP or a minimal viable product and the whole full workflow. We're hoping to have that done by June, and then we want to start testing it with our initial use cases. And then we want to create more safe policy workflows, because without the workflows, it's going to be really hard to have other people adopt it, because the language is such that we're going to have to give people templates. It's not something that IRBs and policy deciders are going to be able to do. We're going to have to create tools for that. We're hoping going into the future that we can do some really creative ways to manage that, and look at how maybe we can do some natural language processing or look for certain types of things within the text that tie to certain policies. Now, that's not part of this grant, but that's something that several of our funders are interested in. And then we're looking for early adopters. Hopefully early next year, we'll start looking to people outside of our test cases here at UNC. And I really see this as some bigger, broader impacts for TRSA. Big data, as well as sensitive data. Data that can't be moved into Dataverse could be create the metadata, push that metadata in, and with this change that we're working on, Dataverse would be able to reference that data. And then people could run tools on that data using that reference. As I mentioned earlier, encoding the policies are going to be the hard part here. We've already got a handful that for our use cases here at UNC and at Duke, but what we'd like to do is create some more and more generic policies and create tools that help people encode their policies into this safe language. And then we'd like to expand the storage drivers. Right now, TRSA is going to sit on, it's a web service sitting on top of a storage system, and it is accessed through HTTPS, and Presidio is the HTTPS gateway. It's the manager for that gateway, but we also see the ability to add Globus as an endpoint there. iRods is really popular in Europe, and something here at UNC that's used a lot. We're hoping to have an iRods client under TRSA, as well as Amazon S3. So those are the three we're interested in, but I think there will be many, many, many other options. So the main thing I want to mention is that there's tons of people working on this. So anything I've said that's wrong, that's my fault. Anything that I said is right, it's got to be one of these other people. We've got lots of people working on this. We have teams in multiple universities really trying to pull together all of these different technologies. And, you know, it's been a lot of work individually, but now we're starting to come and pull all this together as the major workflow. And it's led by Ilya Baldwin at RITSI, is my compadre for this. The team is based here at RITSI at UNC, but as I said, we have folks in several other universities working as well. So I think that's all I have, and I hope I've not just babbled on and on and on, and I want to get some questions now.
Go ahead and type your questions into the chat, or feel free to unmute yourself and ask your question if you'd like to, folks. I'll start if I can, John. This is Courtney.
Yeah.
So one question I think about, because we have needs, especially not necessarily for the sensitive data coverage, but for the remote storage agent for larger data sets here in Texas. And we've got multiple use cases that require that. And one of our biggest concerns in conversations we've had so far is keeping aligned with core Dataverse development.
Yes.
So how have you been discussing that
So we've been working with the folks up there at Harvard, and we're trying our best to not, to be honest, we could have done this a lot faster if I'd have just said, do it for this impact project. We could have went and made some changes. We've actually made in our test impact, we've made database changes. We made all sorts of changes in there to test things. But I'm really, really committed to doing it for the community, not for impact. At some point, I have to provide a real product for the National Science Foundation, right? So I'm going to have to move on one way or another. But I think that the number one thing that groups like the GDCC and all the different Dataverse communities can do is help coordinate this stuff. And I think that's our biggest need as a community, is to coordinate what goes inside the core versus what do we build using APIs that don't touch the core. That's easier said than done, and I do realize that. But I think that's the next biggest thing. And once we get this, I've been trying to encourage everyone to think about all of these modifications to the core as not just for you, but for the community. So I don't want just a notary service button in my Dataverse. What I want is an external storage location button. And then that's configurable by the Dataverse instance. And I think we need to have multiple remote storage per Dataverse. I think even in your Dataverse, you may have multiple remote storage locations from various sources, and different groups may have different requirements for their group. So I think we need to think broader as we're doing some of these things. It is a big challenge, though, Courtney. You're exactly right.
Well, I'm glad you're thinking about it. I really appreciate that, because it's one of the things that we think about here too. And I especially like what you said about having, that drop down to remote storage allow for multiple options, because one of the challenges we're looking at is, if, for instance, UT Austin and Texas Tech, all, they both want to use their local storage for their bigger data sets. But they also want to use, for their smaller data sets, they might want to continue to use the TDR storage.
Yeah.
And so I'm really glad that you're thinking along those lines of
I think it's
drop-down
critical
for multiple. Yeah, I think so too.
I think it's critical. And the people at Harvard and everyone I've talked to agrees it's critical. The question is, how do we proceed and still keep deadlines met? That's the harder part. I've actually done some use testing, and some of you folks have probably have too, with the new Dataset page, the look and feel of it. And if you look at it, it has a lot of these components, and they're preparing for this. They're preparing for buttons that are at the dataset level, buttons that are at the individual file level, and being able to configure those access points dynamically. I think that's coming, and I think that as a community, it would be good if we can get together and coordinate that.
Yeah, I think we've got some momentum, driven largely by your project. So thank you. Any other questions, folks, in chat here? We've got 1 minute left before we have to say goodbye to John. I don't see typing, so I'm going to take this opportunity just to thank you, John, and tell you I appreciate it. I'm really looking forward to when you start testing with your early adopters and hearing about some of the feedback that you're getting from users. And I also look forward to seeing you in Cambridge this summer.
Yeah, and I hope we have a full. So rather than going from TSR from the trusted storage agent to Dataverse to Notary Service, hopefully we go from there to the enclave and then see the data in the enclave, so we can do the full loop by then.
Yes. All right. Well, more power to you. Good luck. All right.
Thank you.
All right. So thank you very much, and thank you everyone for joining us today. We look forward to our June edition of this series. We're skipping May, but in June we will have Sonia Barbosa from Harvard Dataverse talking to us about outreach. So take care. And again, thank you, John.
All right. Sounds good. Thank you.
Bye-bye.
All right.